Okay, hello, welcome back to another one of my video log recording sessions. Date is 2025, March 13th. As I've mentioned in my previous video about measuring performance or performances, assessing performances with a different metric that is computed differently. Yeah, as I mentioned that this notebook is the beginning of that exactly, and this Jupyter notebook is titled Genetic Algorithm 0 Rev, as in revised. So almost everything is the same except a few changes. For example, quite a minor change is this one. I imported copy in order to make deep copies when I create the void genes, the initial population full of void genes, and then downwards we have there are 20 items in this notebook, and therefore 20 constraint values and 20 utility values, like so. And here are the functions. They're exactly the same functions, except this one has been added. This function takes in the entities dictionary and calculates the average of top given percentage entities. For example, if it's top 10, I would put in 0.1 in the percentage, and it would calculate how many entities that is and round that up, and then calculate the weighted average. So if there are two entities with the top score, it would be the top score times 2 plus however many entities there are in the next key of the dictionary times the key, plus on and on and on until that number is satisfied, and until that number is met, and divided by that number in order to compute the average. And if instead of a decimal number, a float, the word head or tail is given, head will give us the top entity, the summed utility score of the top entity, and the tail will give us return the bottom summed utility score of from the entities dictionary. And for this notebook, I used the less favoring highs procreate function, because less favoring highs, where the weights at which the entities are chosen are computed by dividing the population size by 1, 2, 3, 4, 5, 6, and on. This is what I used initially when I started this project. So I brought this back, except that this time I'm using the function instead of writing everything out in the evolve cell, and that's it. So the hyperparameters, with the number of items being 20, the max constraint is 4,000, the physical weight threshold is 4,000, population size is 500, and generations is 500. So that's the total number of generations that the entities will go through the evolution for. So, and we adjust the list, and this is redundant, but I kept it. This is the part where I used the deep copy, and because if I just used copy in the future, I could have some instances where alterations, some changing of values in the list, within the list, will replicate itself throughout the outer list, and that's a problem. So I changed it to deep copy. I didn't want to import another library or module, but because I wanted to rely on the most basic ones, but in this case the copy library seemed to be quite basic, so I brought that along. And I start the evolution, and while I'm doing that, I have 4 result lists. One for storing the values for the summed utility value, the top sum utility value of that generation. Another for the bottom summed utility value of that generation, respectively named head and tail. I didn't want to keep calling it top or bottom. And then the third list is the top 10%, meaning the average of summed utility values of the top 10% entities, and 50%, the average of summed utility values of the top 50 entities. So I initiate that, I create that. I created it here as well, but as a redundancy, but I know I can either remove one of these, but some redundancies are good as long as I know where they are. I know it's bad coding practice. So I start the evolution, and this is how much it took on this Google Colab environment. So 163 seconds. On my laptop, it took about 45, 42, 43, 44, 45 seconds, so about 40 something seconds. What is this? So again, Google Colab is about 4 times slower, but one thing to note is that I think because of the newly added processes, these steps to calculate the averages, the runtime has increased by about 80% maybe, I think. So it's not good. So in the future I would need to either find a better way of doing this, or optimize and then not do this ever again, or make an option to toggle this functionality or functionalities on and off. So that's something I should do in the future. So 163 seconds. And here are the assessments. And when I do this, this is the plot for the head values. As you can see, this is kind of not easy to decipher, so I'll just let 4 lists to show, and the maximum being 710. Maximum is 710, as I have established many times. If you see here, you will see that the plots sometimes do hit the maximum ceiling, so that's okay. It's not bad, that's good. This is the plot for the tail values, and again, as predicted, they're very low. So interesting, but not that interesting, depends on how you look at it. And this is when you plot the heads and the tails together, so a huge difference. I mean, naturally, this is all very normal. Before we look at this, this is the plot for the top 10%. You can see the ceiling, the plot ceiling is 750, maximum 710, and there we go. Yeah, so this is quite similar to what we've been seeing all this time in my past videos, and this is the top 50%. So it's slightly below 500, whereas here it's slightly below 600. And coming back to this is the plot of heads, the tails, the absolute tops, absolute bottoms, and the top 10%. So this is again as expected, so all very normal. And one way to study the distribution of the final entities dictionary is this. I think I've shown this in my previous video. I make the entities dictionary count, entities dict count dictionary, and I count the number of entities for each key, and I put them up. I put the result on a scatter plot, and here we go. Nice. And I don't think any dictionary, any entity has hit 710, or not yet. I don't know. Could be, could not be. Sometimes it did. In the last run it didn't. That's the right way to say it. This is the same thing, but in the form of a bar chart. Trying to decide which one's easier for the eye, or eyes rather, because I have two eyes. Yeah. So this new function, compute average summed utility, is what I'll be using for the rest of the revision phase. Throughout throughout that phase, and I will have to sort of retrace and redo the steps that I have previously done, like testing with the mutation rate, and then using the function again, and also getting the distribution, testing the numbers for the population size, testing the number for the generation, etc. So that's what I'll be doing. But I don't think I need to redo every single one of them. I just need to do the very crucial ones, the ones that actually gave me a solid, hard takeaway, a lesson. So for those, I'll definitely be doing that, and I think that's about 4 to maybe 6 videos in total. Yeah, so that's about it. And one of the things that I aim to find out would be whether using this new metric would also lead us to having dips. And I think, spoiler alert, I think it might, because I think I have already seen sum. So I think it does, but I still have to you know, make sure that it actually does. So yeah, so that's about it. Thank you for watching. Bye.